All right, so let's do a quick Bayes problem. Here I have just something from our prep materials, and I wanted to go over it again for class. So here we go. Fishing line by a company is tested for strength. The test gives a correct positive result with a probability of 0.85 when the fishing line is strong, but gives an incorrect positive result, false positive, with a probability of 0.04 when in fact the fishing line is not strong. If 98% of the fishing lines are strong and a fishing line chosen at random fails the test, what is the probability it really is not strong? Okay. So with any of these problems, the first thing I do at least is I start writing down what I know. So what do I know? I know the probability that something is strong, right? Which is 0.98. And I'm just going to point out that in this question, we also are going to need to know the probability that something is not strong, right? So let's consider that. Let's also get the probability of something being not strong, the line being not strong, which is just 1 minus strong, okay? We have the test gives a correct positive result with a probability of 0.85 when the fishing line is strong. So given that it's strong, right, it's going to be positive 0.85, probability of 0.85. So positive given strong is going to be 0.85. And let's notice some other things that we might need. What is the, it gives an incorrect positive result, so positive with a probability of 0.04 when in fact the fishing line is not strong. So positive given strong, we also need positive given, not, or we also have here positive given not strong, which is going to be 0.04. We're going to need to know not positive at some point. And to compose not positive, we need the complements of both positive given strong and positive given not strong. So why don't I go ahead and say not positive given strong, right? Not positive given strong is going to be 1 minus this positive given strong. Positive given not strong, well, the complement of that is simple, right? It's just not and then 1 minus positive given not strong. Okay, so we should have everything we need here. Recall Bayes' theorem. Let's try to remember the question we're actually asking. What is the probability of it being not strong given that it tested not positive? Okay, so not strong, and I'll just do this in somewhat more standard notation. So the probability of it being not strong given that it tested not positive. Well, according to Bayes' theorem, this is going to be the probability of it being not positive given that it is not strong, multiplied by the probability of it being not strong, and then that's going to be divided or normalized by the probability of it being not positive. And I'll, instead of doing not P, I'll do not positive instead. Okay. All right, so what don't we have here in our Bayes formulation? Well, we don't have not positive, right? Let's see, not strong given not positive is what we're trying to figure out. So we don't have not positive. How do we figure that out? So the probability of it being not positive is going to be, it's going to be a composition, okay, of the different ways that it can be not positive. And what we've got here is not positive given strong, okay? And we've got not positive given not strong. So we're going to compose this probability with these in some way. So probability of not positive given not strong, which we want to weight by the probability of it being not strong. And we're going to sum that with, in order to create this composition, we're going to sum that with the probability of it being not positive given that it is strong, multiplied by or weighted by the probability that it is strong. So let's just translate this into Python. We'll just fill in all these blanks. So this is going to be not positive is going to be not positive, right? That's a simple way that we can do that. And the probability that it's not positive given not strong, well, do we know that? We do, right? We've got it right here. We've got not positive given not strong. So I'll just replace that. The probability of not strong, well, we've got that up here. That's just the complement of it being strong. The probability of it being not positive given that it's strong, do we have that? We do. We have it here. Not positive given strong, we have here. And the probability of it being strong, which we have up here. So where do we go from here? Okay. We've got not positive. This is our law of total probability calculation. This is giving us the universe of not positives, or the subset of not positives. And it's simply a composition of the not positive given not strong and not positive given strong, weighted against the probabilities of not strong and strong. So from there, we can build out this Bayes calculation. And I'm just going to take all this and, again, translate this into just simple Python. So not strong given not positive. I'll just do not strong given not positive. The probability of it being not positive given not strong. Well, we have that up here, multiplied by not strong. We actually have that. We have that in our prior calculation, our calculation of the normalizing constant, or whatever you want to call it, our denominator, right? And we've got our denominator. So we should be able to just print these. And I'm going to go ahead and print the not positive value, right? Our law of total probability calculation. I'm going to also print our not strong given not positive. And let's see what we get with that. Python delme.py. And it looks like the probability of it being not positive is 0.1662. And the probability of the line not being strong, given that it's not positive, is 0.1155. So right there. These problems can be tricky to interpret. You know, that's kind of the thing. When you see this style of textbook problem, often you're just initially trying to figure out what they're asking. And this one I find tricky because of all the complements, and it just gets, you know, it gets a little topsy-turvy in my head, right? Not everywhere. So hopefully that's helpful, and let me, you know, in the comments if you have any questions about this, let me know, please.